Hi everyone and welcome to my YouTube channel. So in this video, we'll continue with this year's IMO 2022, which was held in Norway. So in the previous video, we discussed the first problem 1 of the day 1. That was a combinatorial problem. So as you know, in the IMO we have 2 days, day 1 and day 2. And on each day we have 3 problems, like the first one is easy, the second one is medium, and the third one is hard. So as you can see, like this problem 2 is considered to be medium. So actually we will see that when we will discuss the problem. Okay, so what is this year's problem 2 in the IMO? So actually it was a functional inequality. So like this problem is between like a mixture of functional equations and inequalities, because as you can see here we have a functional inequality. Okay, so actually if you guys have been following this channel, then you should be familiar and you should have experience dealing with functional equations, because we uploaded a whole functional equation course. So I hope you guys are excited, and one piece of advice is that please try to pause the video and try the problem yourself, just to see, especially if you've been following the course, to see yourself the difficulty of IMO problems, and then of course let's get started. Alright, so the problem statement goes as follows. So we need to find all functions f from r positive to r positive, that is the set of all positive real numbers, so 0 is not included here, such that for each positive real number x, there is exactly one positive real number y, satisfying the following inequality: x if y plus y if x is less than or equal to 2. Alright, so that means for each x there is exactly one y that satisfies this inequality. So that means, of course, logically, that all other y's, all other real numbers, positive real numbers, satisfy the opposite inequality. That means this is strictly greater than 2. Okay, perfect. Okay, so what is the first thing to start to do when solving a functional equation or a functional inequality? It's the same principle. Okay. Of course, usually we substitute. However, take a look here. What will we substitute with? Shall we substitute with numbers? Well, of course, you cannot substitute both x and y, because you don't know what exactly is happening. For each x, there is a special y for it. So it makes sense to start by simply guessing what is the solution. And in fact, one bonus thing is that usually the solution, when you figure out the solution, when the problem does not have a very clear solution, usually that worth a point actually. Of course, not just stating the solution, but proving it at least. Okay, so let's try to think of a solution. So what do you think? Maybe the constant function works. Let's put c, for example. So what about xc plus yc? So that's c times x plus y. Do you think it is a solution? Well, clearly not, right? Because you cannot say that there is exactly, for each x, there is exactly one y that satisfies c times x plus y is less than or equal to 2. That doesn't make sense, right? Okay, so the constant function doesn't work. What about f of x equals x? Well, take a look. Clearly that does not work, because we will have xy is less than or equal to 1 for only one number. Of course, that doesn't work. In fact, that doesn't hold at all. In fact, you can see that any linear function doesn't work. Okay, so what should we think of in this situation? So actually, if you're familiar with a very simple inequality that's derived from the AMGM inequality, you should have already guessed the solution, which is f of x equals the inverse of x, that is 1 over x. Because you should be familiar with the fact, if you, for example, here put f of x equals 1 over x, you will immediately get the following. So let's take a look. Something like this: x over y plus y over x. So if you're familiar with the AMGM inequality, you should already know that this is greater than or equal to 2, with equality holding only when x equals 1. And in fact, this already shows that this is the function we want. Because take a look. if f of x equals 1 over x, then this expression is this. And we know that this is strictly greater than 2 when y does not equal to x. So indeed it works. And there is only one positive real number y for each x, that is x itself, that satisfies that this is equal to 2. Alright, so that of course like when y equals x, we have x over y plus y over x is indeed less than or equal to 2. In fact, it is equal to 2. And when y isn't equal to x, then we indeed have x over y plus y over x is strictly greater than 2. So indeed this works. And like if you're not familiar with the AMGM inequality, like this is not a big deal. Like you can get this inequality easily if you notice that, like just by this expansion. Like take a look at this. Just square this. Clearly this is greater than 0. If you just like expand this, you will get x over y plus y over x minus 2. So like taking the 2 to the other side, you will get this inequality. Alright, so what does that mean? That simply means that we have found indeed like one solution of the problem. Like we are not sure if it's the only solution of the problem or not, but we know that it is a solution. And probably like it is the only solution here. Okay, so first of all, like let's create our magical solution box here. So like the solutions. And we already know that f of x equals 1 over x is a solution. In fact, like if you were in the IMO and you wrote that f of x equals 1 over x just like that is a solution, like that doesn't give you any mark. However, if you prove it, like just like we did here, we will immediately get 1 point immediately. And in fact, this is really good and not difficult at all by just like guessing and proving it. All right, so now we've found our solution. So we need to prove that this is the only solution that works, right? Okay, so like we just like do it by contradiction. So let's assume there is a function f that satisfies this condition and it's not 1 over x. Okay, so what does that like? What shall we do now? So first of all, like here the statement is like not that cool to deal with. So instead of like saying for each x there is exactly one y that make this inequality holds, let's just like turn this into symbols. So I'm just going to use the tilde symbol to link between x and y. So let's just define the following operation. So let's say x tilde y is equivalent to x if y plus y if x is less than or equal to 2. Alright, so if we have x tilde y, that means that this equation, or sorry, this inequality holds. Like you can immediately see that like the tilde operation, like you can swap these, right? Like if x tilde y, then y tilde x. Because take a look, this is symmetric, right? So like if you replace x with y and y with x, like you will get the same, right? X if y plus y if x is less than or equal to 2. Alright, so if x tilde y, then y tilde x. This is like our first our first thing that we should notice immediately. Alright, so now we just like need to forget about this and just like use the tilde notation. Alright, so now we want to show that f of x equals 1 over x. So as you can see here, like what in this case when f of x equals 1 over x, like what is the tilde, like x tilde what exactly? Well, clearly x tilde x itself, because like this only holds when y equals x, right? So that means x tilde x. Alright, so like maybe the first thing we should do is to prove that x tilde x in our function inequality, because like this will already be halfway of the solution. Okay, so maybe we can show that x tilde x in our function inequality. All right, so let's actually assume that like the contrary, that x doesn't tilde y, or sorry, x. So what does that mean? Okay, So let's now assume that x doesn't tilde x. Okay, what does that mean? Well, that means that there exists y that is different from x, such that, of course, x tilde y, right? Perfect. Now, of course, like y tilde x as well. Okay, so what does it mean that x doesn't tilde x? What does that mean? Well, that means like the opposite of this inequality work when we substitute y with x, right? Okay, so let's actually write that. So that means that x if x plus x if x, that is 2 times x if x, is greater than 2. So that means that x if x is greater than 1. That means that f of x is greater than 1 over x, strictly greater than 1 over x. So let's write that down. That immediately means that f of x is greater than 1 over x, because as we mentioned, x doesn't tilde x. That means the opposite of this work, like this is greater than 2 when we substitute y with x. So we'll get 2x if x is greater than 2, meaning that f of x is greater than 1 over x. Perfect. All right. And of course, because x tilde y, that means that like this holds already, right? Like x if y plus y if x is less than or equal to 2. However, now take a look. We know that f of x is greater than 1 over x. Like that in fact holds always when x doesn't tilde x. So like for any x that satisfies x doesn't tilde x, we have this, f of x is greater than 1 over x. So like maybe we can substitute it here at this inequality to get like a contradiction, because take a look, we know that this is less than 2, less than or equal to 2. However, we can like now we know that f of x is greater than 1 over x, so this is greater than y over x. But what about f of y? Can we apply the same for f of y? Well, if you want to apply it, you should check that y doesn't tilde y, right? Because this is like this, the necessary condition to conclude this. So, like can y, can, for example, y tilde y? Well, in fact, no, because we know that y tilde x, and x is different from y, right? And we have only like one number, exactly 1, remember? Okay, so that simply means that y doesn't tilde y, so that means in fact f of y is greater than y. Greater than 1 over y. Alright, so what does that mean? Let's take a look. Let's consider this. X if y plus y f of x. So we know this is less than or equal to 2 from here. And we know that f of y is greater than 1 over y. That means x over y. And f of x is greater than 1 over x. So this is y over x. So guess what? Now we know that x over y plus y over x is less than or equal to 2. Well, we know from the AMGM, we've just like proven that in fact this the opposite inequality holds, because we know that this is greater than or equal to 2, right? In fact, what does that mean? Like the only case that this is possible is when it is indeed equal to 2, and the equality holds when x equals y. A contradiction, right? Because y isn't equal to x. So like our whole statement is wrong. So that simply means that indeed x tilde x. Perfect. So now we're halfway to the solution. You can see like this discussion isn't like really complicated. It's all about just like here we introduced the tilde notation, and we immediately just shown that x tilde x. Just because here we realized that in our solution x tilde x, so it makes sense to show that x tilde x, and in fact this is really simple. Alright, perfect. So now we do indeed know that x tilde x. So let's erase that now. Alright, so now we know that x tilde x, so let's write that down here. So this is really simple, just like x tilde x. Okay. Well, what does that mean, that x tilde x? Well, that actually gives us one bonus inequality. Well, take a look here. We know that if x tilde y, then we have the following, right? So that means that we can simply substitute y with x, because we know that x tilde x. Okay, so let's actually substitute that. So we will get x if x plus x if x is less than or equal to 2, meaning that x if x is less than or equal to 1, meaning that f of x is less than or equal to 1 over x. Perfect. So in fact now we have another nice inequality. Let's write it here. And that is actually f of x is less than or equal to 1 over x. Like this is really nice, right? Like this inequality, f of x is less than or equal to 1 over x, because we want to show that f of x equals 1 over x. Here we know that it's less than or equal to it, so we just need to show that the equality holds. Okay, so what to do next? Okay, so actually here, like, I will tell you something that, like, I usually prefer to do. Like, in fact, you don't have to do it in order to solve the problem. You still can solve the problem with, like, your function f. However, like, one thing I prefer to do, like when I have some inequality, like when I reach some inequality, especially when I have like a function that is from r positive to r positive. Well, what does like r positive to r positive mean? Like this already tells you that f is positive, right? So that's good. So when you reach some inequality like this, and you don't know how to use it, well, simply, like my way of thinking, I simply define a function g, like it's still from r positive. So I define it like to forcefully like make this useful. So how to do that? Well, take a look here. If what happens if we define g of x as 1 over x minus f of x. What do you think about that? Well, we know that g is from r positive. All right, but because we know that 1 over x minus f of x is positive, that means it's also like from r positive to r positive. However, like here it's not r positive really, because like here we have 0 as well, something like that. Like it might be 0. In fact, we want to show that g is the 0 function, and we will be done if we can show that. And the nice thing is that you can write your function equality simply with g. Like you can express now this relation like using g, and it won't be difficult at all. So let's take a look. Okay, let's take a look now. So as you saw, like why did we do this technique? Just in order to like use this inequality, like because we didn't know how to use it. Now like we have already used it in our definition, like because now we know that it's from r positive to r positive with the 0. All right, so like this is the intuition behind this, like the definition of g. And like this is in fact a standard idea, which was I believe, I'm not sure if we discussed it before, like it was in one shortlist problem from the previous shortlist, like IMO shortlist problems. Okay, so now let's let's express everything with g instead of f. All right, so now in fact we can even erase this. All right, so now let's take a look. So if g of x equals 1 over x minus f of x, so that means that f of x is just 1 over x minus g, right? So let's like replace each f with 1 over x minus g. All right, so that will be x over y, and that will be y over x. So we'll get something like this. X over y plus y over x minus, so here we'll have x g of y minus y g of x, and this is like less than or equal to 2. All right, so now we can take this there and this there, and you can already like see something interesting, right? Like take a look, x over y and y over x. We know that this with the 2 like can be factorized, right? So let's do it. Let's factorize it. So let's take these to the other side and this here. So this will be in fact simply square root of x over y minus square root of y over x squared, and this will be less than or equal to x gy plus y gx. All right. So actually now, like the problem is like the following. If x tilde like y, then we have this. However, remember, we've shown that x tilde x. That means the opposite of this inequality holds for any like two pairs, for any pair x, y, such that x like is different from y, so they are distinct. So in fact, we can just reverse this. So in fact, this is like this for any like x isn't equal to 1. All right, let's take a look here. Let's focus now here. Okay, so now I want you to take a look at this relation and try to finish the problem immediately, actually, with just this relation. All right, so take a look here. Like, we cannot substitute x with y, right? Because take a look, if we substitute x with y, from here, we know that we cannot substitute x with y because we will get the opposite inequality. However, if you replace x with y, the left-hand side will be 0. And the right-hand side, that means, is less than 0. Well, a contradiction, because it cannot be less than 0 unless the g's are 0, right? In fact, this is what we want to show. So we cannot like really replace x with y because, as we mentioned, x is different from y. However, we can take a limit here. So we can take, for example, y, let y approaches x, and the left-hand side will be approaching 0, and that means simply the right-hand side will be approaching 0. However, like, because we don't want like to have g of y and y at the same time, like we can actually, because like this is a greater sign, we can immediately even get rid of this. Like we can like assume that this doesn't hold, like, or sorry, this is like it isn't there, because take a look, I can simply say that the right hand side is for sure greater than what just y g of x. So in fact, I can say that the left hand side is greater than, strictly greater than y gx alone. And now if I take y approaching x, what do I get? The left hand side for sure is approaching 0. That means the right hand side is also approaching 0. So that means that because we know that the right hand side is actually approaching x gx, that means x gx is approaching 0. What does that mean? Well, that means that the only way for this to make sense is gx equals 0. And ladies and gentlemen, if gx equals 0, that means that f of x equals 1 over x, and that means that our solution is indeed f of x equals 1 over x, and we'll be done, just like that. All right. So basically, like, this was the problem, the second problem of the IMO. All what we did was, first of all, guess the solution, prove it works, simply, that in fact works 1 point. Then we noticed that in our solution x tilde x, so we need to show that x tilde x here. We did that immediately. It was not difficult at all by doing a contradiction statement. And then after showing that x tilde x and getting the inequality that f of x is greater than or equal to 1 over x, all what we did was to define the function g and to use the fact that it's from R0 to R0, and we immediately got this new, this simple functional inequality, and just by taking a limit here, we immediately killed the problem. All right, my friends, so that was our second problem of this year's IMO. So in fact, in my own opinion, I believe that this is not really a medium problem. However, it's more of an easy problem. Because take a look, what did we do here? We immediately guessed that f of x equals 1 over x and prove it. This was not difficult. Then, just showing that x tilde x, that isn't also difficult at all. You can see, it was not even, one line. The idea even, was really simple, just, by contradiction. And then, the third idea, maybe, this is the only idea of the problem, that to take g of x equals 1 over x minus f of x, I believe you don't, in some solutions, they didn't even define g. So you can even, do the same, statement here with just, if immediately. However, for, a much neater solution, I believe, replacing, defining g is helpful because, you can use the inequality that we got f of x is like less than or equal to 1 over x, or sorry, yes, exactly, 1 over x is greater than or equal to f of x, like here forcefully you can use it, and like that was also a standard idea from the IMO shortlist. So immediately got this inequality, and from here actually to take the limit is not really difficult. You should be familiar, like especially when you have inequalities, you should always think about the limit cases, especially when you have r positive, because like here, like you want something to be negative to get a contradiction, so like you get that it is 0. So as you can see here, like that was simply the idea. So I believe like this was not a really difficult problem. Like please feel free to tell me in the comments what do you think about this problem. And in fact, actually this year's, like just a spoiler, like the IMO medals like went really high, like the cutoffs were really high. We will discuss that like later in our later videos. Okay, my friends. So in this video we solved the second problem of the day 1, and in the next video we'll be solving probably problem 3, which is considered to be the most difficult of the day 1. Of course, the day 2 we have the most difficult problem is problem 6. Okay, my friends, so I hope you found this video fun and you learned something from it. So if you did, please like, share and subscribe to the channel, and see you guys in the next video.